Hello, in this lecture we'll find out the area of the semicircle using 4 different methods. In the drawing we have a semicircle that is inscribed by triangle ABC. Triangle ABC is a right triangle. Angle ABC equals to 90 degrees. Side CB of triangle ABC equals to 5 units. Side AB of triangle ABC equals to 12 units, and we want to find out the area of this semicircle. So first of all, we will define the center of this semicircle as point O. And actually OB is the radius of this semicircle because of the fact that line segment OB starts from the center of the circle and ends at point B, that is a point on the semicircle itself. Therefore OB is the radius of this semicircle, and we will define the radius of the semicircle as R. Therefore OB will be equal to R. And what is the length of AO? AO equals to AB minus OB. So I'll write it down. Line segment AO equals to AB minus OB. So AO equals to AB equals to 12 units. It is given us the question. And OB is the radius of this semicircle, that is to say it equals to R. So we actually found out that AO equals to 12 minus R. So we can write here that AO equals to 12 minus R. In the next step, we will define the point of tangency of tangent AC with this semicircle as point D. Then we will join points D and O together by a straight line. Actually, DO is the radius of the semicircle because of the fact that it starts from the center of the semicircle, that is to say from point O, and then at point D, that is the point on the semicircle itself. Therefore, DO is the radius of the semicircle, that is to say it equals to R. And in the next step, we will find out the length of the hypotenuse CA of the right triangle, triangle ABC, and we will use the Pythagoras theorem on the right triangle, triangle ABC, in order to find out the length of the hypotenuse CA. So we will focus on the right triangle, triangle ABC. So in the right triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle, triangle ABC, is equal to AC. So it is the square of the hypotenuse is CA square and it equals to the sum of the squares of the perpendiculars, that is to say it equals to CB square plus BA square. I will repeat again. In the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say CA square equals to CB square plus BA square. So CA square equals to CB square. CB equals to 5 units. It is given as the question. So CB square is 5 square, and 5 square is 25, plus BA square. BA equals to 12 units. It is given as the question. So BA square is 12 square. 12 square is 144. So in conclusion, we found out that according to equation number 1, CA square equals to 25 plus 144, 25 plus 124, 25 plus 144 is equal to 169, so I'll write it down. So CA square equals to 169 according to equation number 1. Here we'll take a root out of this equation, equation number 1, and we will get that CA equals to the square root of 169, and the square root of 169 is equal to 13. So we found out that CA equals to 13 units. So we can write here that CA equals to 13 units. In the next step, I will present to you a new rule, rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So I will read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle if we have this circle and the center of this circle is at this point, we'll define the center of the circle as point O, and we also have tangent AB to this circle, here tangent AB, this tangent is tangent to this circle at this point. We define the point of tangency as point M, so point M is the point of tangency of tangent AB with this circle. And we join together points O and M by straight line. So here you can see, and OM, it is actually the radius of this circle because of the fact that it starts from the center of the circle and ends at point M, that is the point on the circle itself. Therefore, OM is the radius of this circle. So you can see that the radius OM of this circle, it is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so according to rule number 1, a tangent to a circle, that is to say AB, is perpendicular to the radius drawn to its point of tangency. So whenever you have a radius like in this drawing that is drawn to the point of tangency, like here that the radius OM, it is drawn to point M, that is the point of tangency, then the tangent AB will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so we can implement rule number 1 in our drawing, because in our drawing we have point D. Point D is the point of tangency of tangent AC with this semicircle, and we have the radius OD is drawn to the point of tangency. That is to say, it is drawn to point D, that is the point of tangency of tangent AC with this semicircle. Therefore, according to rule number 1, the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so here, because of the fact that this angle ADO is a right angle, then triangle ADO is a right triangle. Okay, so here the green triangle ADO is a right triangle. So in the next step we will focus on the right triangle ABC, and on the green triangle ADO. And we will prove that triangle ABC is similar to the green triangle ADO. So we'll focus on triangle ABC and triangle ADO. And we'll prove that those two triangles are similar to each other. Why those triangles are similar to each other? First of all, we have those two angles. They are both right angles, therefore they are equal to each other. So this angle, that is angle ABC of triangle ABC, is equal to this angle, that is actually angle ADO. And they are both equal to 90 degrees. So here angle ABC of triangle ABC equals to angle ADO of the green triangle, and they are both equal to 90 degrees. And we also have this angle. This angle is a common angle. It belongs to both triangles. So we can write down that angle A equals to angle A. It's a common angle that belongs to both triangles. I'll repeat again. Angle A equals to angle A. It's a common angle that belongs to both triangles. And we also have those two angles that are also equal to each other according to third angle theorem. So this angle, that is actually angle ACB of triangle ABC, is equal to this angle of the green triangle, triangle DOA. Is equal to angle AOD of the green triangle according to third angle theorem. I repeat again. Angle ACB equals to angle AOD, and they are equal to each other according to third angle theorem. So what is the third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we have here those two angles in triangle ABC, from triangle ABC, congruent to those two angles of the green triangle. Therefore, we have here two pairs of angles that congruent to each other in those two triangles. Therefore, the third pair of angles, that is to say those two angles that are defined as the third pair of angles, must also congruent. Why? Because they are complementary to 180 degrees. As you already know, the sum of the angles in any triangle is equal to 180 degrees. And when you have two angles, two pairs of angles that congruent, then the third, in two triangles, then the third pair of angles must also congruent because they are complementary to 180 degrees. Okay? So we found out that all the angles inside triangle ABC congruent to all the angles of the green triangle. Therefore, we can conclude that triangle ABC is similar to triangle ADO, the green triangle. Triangle ABC is similar, this is the sign of similar, to triangle, the green triangle, triangle ADO, according to angle similarity rule. I'll repeat again. Triangle ABC is similar to the green triangle, triangle ADO, according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then the third pair of angles must also congruent. Okay? And from the fact that triangle ABC is similar to the great triangle ADO. We will conclude that CB over CA in triangle ABC. Again, CB over CA in triangle ABC is equal to DO over AO in the great triangle. The great triangle ADO. I will repeat again. From the fact that triangle ABC is congruent to, from the fact that triangle ABC is similar to triangle ADO, the great triangle, we conclude that CB over CA in triangle ABC equals to DO over AO in the great triangle ADO. Okay? But we know that CB equals to 5 units. CA equals to 13 units. DO equals to R, it is the radius of the semicircle. And AO equals to 12 minus R. So in conclusion, we found out that according to equation number 2, 5 over 12, 5 over 13 equals to R over 12 minus R. Here we will cross multiply equation number 2 and we will get that 5 times 12 minus R equals to 13R. We will open the brackets of this side of equation number 2 and we will get that 5 times 12 is 60 and 5 times minus R equals to minus 5R and it equals to 13R. Here we will add 5R to this equation, equation number 2, and we will get that 13R plus 5R is 18R, and 18R equals to, here 5R minus 5R is 0, so we left only with 60 here, this side of the equation, and we got that 18R equals to 60. Here we will divide equation number 2 by 18, and we will get that the radius of the semicircle R equals to 60 over 18. Here we will divide this number, both the numerator and the denominator of this number, by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle, the thing that we are looking for, is equal to so the brackets here, it means that it is the sign for the area. It means the area of the semicircle equals to pi r squared over 2. That is to say, it equals to pi, r is 10 over 3, and r squared is 10 over 3 squared, all divided by 2. 10 over 3 squared equals to 100 over 9, all divided by 2. 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay, I'll repeat again, the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this semicircle according to the second method. In the second method, I will present to you a new rule. That is actually rule number 2 or 2 tangents theorem. According to rule number 2 or 2 tangents theorem, so rule number 2 or 2 tangents theorem states that the lengths of 2 tangents from a common external point to a circle are equal. I will read rule number 2 or 2 tangents theorem again. According to 2 tangents theorem, the lengths of 2 tangents from a common external point to a circle are equal. So what is the meaning of rule number 2 or 2 tangents theorem? The meaning of rule number 2 is that if we have this circle and we have also this point is point P, and point P is defined as a common external point. It is an external point because of the fact that point P is not located inside this circle nor on this circle, but it is outside of this circle. Therefore, it is defined as an external point of this circle. So if the external point P, we will draw 2 tangents to this circle, then the first tangent will be this tangent, and we will define the point of tangency of the first tangent with this circle as point A. Then we'll draw a second tangent from point B to the circle, and we will define the point of tangency of the second tangent with this circle as point B. And according to rule number 2 or 2 tangents theorem, the lengths of 2 tangents, that is to say the length of the first tangent is PA and the length of the second tangent is PB, and according to rule number 2, the lengths of 2 tangents, that is to say PA and PB, from a common external point, point P is the common external point, to a circle, to the circle, are equal. That is to say, PA equals to PB. So according to 2 tangents theorem, whenever you draw 2 tangents to a circle from a common external point of that circle, then the lengths of those 2 tangents will be equal to each other. In this drawing, PA equals to PB. Why? Because P is a common external point, and from the common external point, point P, we drew 2 tangents to this circle. Therefore, according to 2 tangents theorem or rule number 2, they are equal to each other. That is to say, PA equals to PB. And we can actually implement rule number 2 in our drawing, because in our drawing we have the external point, point C. Point C is an external point. And from the example point C, we have the first tangent is CB, and the second tangent here we have this point D, and here we have DO is the radius, OB is the radius. We did it in method 1, and here we have two right angles. And we know that AO equals to 12 minus R. We did it in method 1. So the first tangent from point C to the semicircle is tangent CB. The second tangent is tangent CD. And according to rule number 2, they are equal to each other. That is to say, tangent CB equals to tangent CD according to rule number 2. But we know it is given us in the question that CB equals to 5 units. Here, CB equals to 5 units. So we can write here that CB equals to 5 units. And from this equation, we will derive that CD also equals to 5 units. Okay, CD also equals to 5 units. So we can write here that CD equals to 5 units. And what is the length? What is the length of AD, line segment AD? You can see from the drawing that AD equals to CA minus CD again. AD equals to CA minus CD. I'll repeat again, from the drawing you can see that AD equals to CA minus CD, but we have already found out that CA, the hypotenuse of triangle ABC, equals to 13 units, and we just right now found that CD equals to 5 units. So in conclusion, AD that equals to CA minus CD, that is to say it equals to 13 minus 5, and 13 minus 5 is 8. So we found out that line segment AD equals to 8 units. So we can write here that AD equals to 8 units. And in the next step we will focus on the green right triangle, triangle ADO, this right green triangle. So we will implement the Pythagoras theorem on the green right triangle, triangle ADO. And according to the Pythagoras theorem, in the green right triangle, triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the green triangle is AO, so the square of the hypotenuse is AO squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to DO squared plus AD squared. I will repeat again. In triangle AD, the right green triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So that is to say, AO square equals to DO square plus AD square. So AO, you can see in the drawing that AO equals to 12 minus R. Therefore, AO square will be equal to 12 minus R square. And it equals to DO square. DO equals to R. Therefore, DO square will be equal to R square plus AD square. AD equals to 8 units, so AD square is 8 square. 8 square is 64. So in conclusion, we found out that according to equation number 1, 12 minus R square equals to R square plus 64. Here we will open the brackets in this side of equation number 1 and we will get that 12 minus R square is 12 square is 144 plus R square minus 24R equals to R square plus 64. So here we have R square on both sides of equation number 1, so R square will get cancelled. And what is left from equation number 1 after we cancelled R square, what is left is actually 144 minus 24R equals to 64. Here we will subtract 64 from this equation, equation number 1, and we will get that 144 minus 64 is 80, minus 24 equals to 0. Here we will add 24R to this equation, equation number 1, and we will get that 24R equals to 80. So here we will divide this equation, equation number 1 by 24, and we will get that the radius of the semicircle R equals to 80 over 24. Here we will divide this number, both the numerator and the denominator, by 8. So 80 over 8 is 10, and 24 over 8 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle will be equal to pi r square over 2. So it is pi and r is 10 over 3. R square is 10 over 3 square over 2. So it is pi 10 over 3 square is 100 over 9 divided by 2. 100 over 2 is 50, so in conclusion we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers it equals to 17.45 square units. Okay, so we actually finished with the second method. In the next step I will present to you how to find out the area of this semicircle according to a third method. Actually, in the third method we will draw a mirror image of this figure. Then we will join together this mirror image. We will join together this figure with its mirror image, and in this way we will get a circle that is inscribed by a triangle. So I will draw a mirror image of this figure, and then I join together this figure with its mirror image. So I drew the original image. This is the original image, and this is the mirror image of this original image, and I joined them together, so we got a circle that is inscribed by this triangle. We will define this point, the vertex here, as point D. We know that AC equals to 13 units, BC equals to 5 units, and AB equals to 12 units. AB equals to 12 and BC equals to 5 units according to what is given as the question. And we already found out that AC equals to 13 units. And because of the fact that this is the mirror image of this image, so because of the fact that AC equals to 13 units, then the AD must be also equal to 13 units, and because of the fact that BC equals to 5 units, then its mirror image DB must be also equal to 5 units. So here we know that the base of the isosceles triangle, triangle ADC, equals to 5 plus 5, and 5 plus 5 is 10 units. Okay? And we will calculate the area of this triangle, triangle ADC. The area of triangle ADC is equal to the base of the triangle times the height over 2. This is the area of any triangle. Again, the area of any triangle is the base times the height to the base over 2. And the base of the isosceles triangle, triangle ADC, is DC. The height to the base is AB. The height creates 90 degrees with the base, as you can see. AB over 2. So the area of triangle ADC equals to DC, DC equals to 10 units, it is 5 plus 5, times AB, AB equals to 12 units, it is given us in the question, over 2. 8 times 12 is 120, and 120 over 2 is 60, so we found out that the area of the isosceles triangle, triangle ADC, is equal to 60 square units. And we can find out the radius of this circle that is blocked. The radius of this circle is inscribed by triangle ADC. Triangle ADC blocks this circle. So the radius of any triangle that is inscribed by a circle is equal to R, the radius, equals to the area of the triangle that blocks the circle. In this case, triangle ADC blocks this circle, so it is the area of triangle ADC that we have already found out that is 60 square units, over the perimeter of triangle ADC. And the perimeter of any triangle equals to its it is actually the semi-perimeter. It is the semi-perimeter, and the semi-perimeter of any triangle is equal to the perimeter over 2. And the perimeter of triangle ADC, the isosceles triangle, equals to AD plus AC plus DC over 2. The perimeter over 2 is the semi-perimeter. So the semi-perimeter of the isosceles triangle, triangle ADC, equals to AD plus AC plus DC over 2. Here, so the semi-perimeter equals to AD is 13, AC is 13, DC is 10, divided by 2. 13 plus 13 is 26, and 26 plus 10 is 36. 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC is 18 units, and the radius of the circle that is blocked by triangle ADC equals to the area of triangle ADC that we have already found out that it is equal to 60 square units, over the semi-perimeter of triangle ADC that we already found out that it equals to 18 units. 60 over 18, here we divide both the numerator and the denominator of this number by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we found out that the radius of the semicircle equals to 10 over 3. The radius of the circle is also the radius of the semicircle, of course, because the circle is composed with the two semicircles, and the semicircle is the semicircle that we are looking for. So the radius of the semicircle is 10 over 3, and the area of the semicircle equals to pi r square over 2. And r equals to 10 over 3, so r square is 10 over 3 square divided by 2. 10 over 3 square is 100 over 9 divided by 2. 100 over 9 is 50, so in conclusion we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers it equals to 17.45 square units. So we finished with the third method. In the next step I will present to you how to find out the area of this semicircle according to the fourth method here we know that this point is point D. We also know that this is O. We did it in the first method, so I will not repeat on it. This is a right angle. This is also a right angle. OB is R. AO is 12 minus R. And AC equals to 13 units. Okay, AC equals to 13 units. We will define this angle, angle ACAB is angle theta, and we will focus on the right triangle, triangle ABC. In the right triangle, triangle ABC, sinus theta equals to CB over CA. I repeat again, on the right triangle, triangle ABC, sinus theta equals to CB over CA, but we have already found out that CB equals to 5 units according to what is given us in the question, and we have already found out that CA equals to 13 units. So in conclusion, we found out that according to equation number 1, sinus theta equals to 5 over 13. I'll repeat again. According to equation number 1, sinus theta equals to 5 over 13. We will focus on the right triangle, triangle ADO. We will focus on the green right triangle, triangle ADO. On the right triangle, triangle ADO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AO because it is in front of the right angle. So the square of the hypotenuse is AO squared, and it equals to the sum of the squares of the perpendiculars. We know that DO is the radius of the semicircle, that is to say it equals to R. So the sum of the squares of the perpendiculars is DO squared plus AD squared. In the right triangle, triangle ADO, sinus theta equals to DO over AO. Sinus theta equals to DO over AO. I repeat again, in the right green triangle, triangle ADO, sinus theta equals to DO over AO. But we know that DO equals to R, and AO equals to 12 minus R. So in conclusion, we found out that according to equation number 2, sinus theta equals to r over 12 minus r. Again, according to equation number 2, sinus theta equals to r over 12 minus r, and according to equation number 1, sinus theta is 5 over 13. So we will create equation number 2 that states that sinus theta according to equation number 1 must be equal to sinus theta according to equation number 2. Okay, so equation number 3 states that sinus theta according to equation number 1, that is actually 5 over 13, must be equal to sinus theta according to equation number 2, that is actually r over 12 minus r. Okay, so here we will cross multiply equation number 3, and we will get that according to equation number 3, 5 times 12 minus r equals to 13r. We will open the brackets on this side of equation number 3, and we will get that 5 times 12 is 60. 5 times minus r is minus 5r, and it equals to 13r. Here we will add 5r to this equation number 3, and we will get that 13r plus 5r is 18r. 18r equals to 60. Here we will divide this equation number 3 by 18, and we will get that the radius of the semicircle equals to 60 over 18. Here we will divide both the numerator and the denominator of this number by 6, and we will get that 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle will be equal to pi r square over 2, pi, and r is 10 over 3, and r square is 10 over 3 square over 2. 10 over 3 square is 100 over 2, is 100 over 9, all divided by 2, and 100 over 2 is 50. So in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So in the next step, I will summarize the lecture. Actually, we wanted to find out the area of this semicircle. We found out the area of this semicircle in 4 different methods. In the first method, here we have a semicircle that is inscribed by the right triangle ABC. AB equals to 5 units, AB equals to 12 units, CB equals to 5 units, and angle ABC equals to 90 degrees, and we want to find out the area of this semicircle. So we define the center of this semicircle as point O. OB is the radius. We define the point of tendency A with this semicircle as point D. We join points O and D together by a straight line. OD is the radius of this semicircle. And we know that AO equals to AB minus OB. Again, AO equals to AB minus OB. AB equals to 12 units. It is given as the question, and OB equals to R. So in conclusion, AO equals to 12 minus R. Then we focus on the right triangle, triangle ABC, in order to find out the length of the hypotenuse CA. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CA square equals to CB square plus BA square. So CA square equals to CB square. CB is 5, so CB square is 5 square. 5 square is 25. Plus BA square. BA is 12. So it is given us in the question. So BA square is 12 square. 12 square is 144. And we got, according to equation number 1, that CA square equals to 25 plus 144. 25 plus 124 is 169. So in conclusion, we got that according to equation number 1, CA square equals to 169. We took a root of this equation, equation number 1, and we got that CA equals to the square root of 169. The square root of 169 is 13. So we found out that the hypotenuse CA of the right triangle, triangle ABC, equals to 13 units. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle, and here the center of this circle is at point O, and AB is tangent to the circle at point M. OM is the radius, and M is the point of tendency of tangent AB with this circle. Here we have the radius OM, it is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius. Okay, I'll repeat again. The radius OM, R, it is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We can implement rule number 1 in our drawing, because in our drawing we have point D is the point of tendency of tangent CA with this semicircle, and we have this radius OD. It is drawn to the point of tendency, that is to say, it is drawn to point D, that is the point of tendency of tangent CA with this semicircle. Therefore, the tangent CA will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So we found out that the green triangle is a right triangle. Triangle ADO is a right triangle. Then we actually proved that the big right triangle, triangle ABC, is similar to the green right triangle, triangle ADO. Why they are similar to each other? Because of, first of all, angle ABC equals to angle ADO equals to 90 degrees. Those two angles, they are equal to each other, they are both right angles. We have this angle that equals to itself. It is a common angle that belongs to both triangles. So angle A equals to angle A is a common angle that belongs to both triangles. And we have those two angles that are also equal to each other according to third angle theorem. What is so actually angle ACB equals to angle AOD according to third angle theorem. What is third angle theorem? Third angle theorem states if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we have those two angles in triangle ABC congruent to those two angles in the green triangle. So we have two pairs of angles that congruent in those two triangles. Therefore, the third pair of angles must also congruent according to third angle theorem. Why they must congruent? Because they are complementary to 180 degrees. Okay, we know that the sum of the angles in any triangle is equal to 180 degrees, and if we have two angles in two triangles that congruent, then the third pair of angles completes the sum of the angles to 180 degrees, therefore they must be equal to each other. So we found out that all the angles in triangle ABC congruent to all the angles in the green triangle, therefore triangle ABC is similar to triangle ADO, the green triangle, according to angle similarity rule. From the fact that they are similar to each other, we will conclude that CB over CA in triangle ABC equals to DO over AO in the green triangle, triangle ADO. CB equals to 5 units, CA equals to 13 units, DO equals to R, and AO equals to 12 minus R. So we got that 5 over 13 according to equation number 2 equals to R over 12 minus R. We cross multiplied the equation number 2 and we got that 5 times 12 minus R equals to 13R. We open the brackets on this side of equation number 2 and we got that 5 times 12 equals to 60 and 5 times minus R equals to minus 5R and it equals to 13R. We added 5R to this equation number 2 and we got that 13R plus 5R is 18R. So in conclusion, we got that according to equation number 2, 18R equals to 60. We divided this equation number 2 by 18, and we got that the radius of the semicircle equals to 60 over 18. We divided both the numerator and the denominator of this number by 6, and we got that 60 over 6 is 10, and 10 over 6 is 18 over 6 is 3. So in conclusion, we got that the radius of the semicircle equals to 10 over 3 units, and therefore the area of the semicircle equals to pi r square over 2. So it is pi and r is 10 over 3 and r square is 10 over 3 square over 2. 10 over 3 square is 100 over 2 and 100 over 2 is 50. So in conclusion we found out that the area of the semicircle equals to either 50 pi over 9 square units or in terms of numbers it equals to 17.45 square units. So we finished with the first method. Then I presented to you how to find out the area of the semicircle according to the second method. In the second method, I presented to you a new rule that is actually two tangents theorem, or rule number 2. According to rule number 2 or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 2 or two tangents theorem? The meaning of rule number 2 is that if we have this circle and we have the external point P, and from the external point P we will draw two tangents to this circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. So whenever you draw two tangents to a circle from a common external point of that circle, then the lengths of those two tangents will be equal to each other, and in this case PA equals to PB. We can implement rule number 2 in our drawing because we have the external point C, and from the external point C we have two tangents to this circle. We have tangent CB and tangent CD. And according to rule number 2, CB equals to CD. CB equals to CD according to rule number 2, but we know that CB equals to 5 units. It is given as the equation. So from this equation we will conclude, we will derive that CD also equals to 5 units. Here CD equals to 5 units, but we know that CA equals to 13. CD equals to 5. What is the value of AD? AD equals to CA minus CD. Again, AD equals to CA minus CD. You can see it clearly from the drawing. CA is 13 and CD is 5. So AD equals to 13 minus 5, that is to say AD equals to 8 units. Then, therefore, the green, if AD equals to 8 units, then we can focus on the green triangle, triangle ADO, and we can implement the Pythagoras theorem on the green triangle, triangle ADO. According to the Pythagoras theorem, in the green right triangle, triangle ADO, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO square equals to DO square plus AD square. AO equals to 12 minus R. So AO square is 12 minus R square. DO equals to R. So DO square is R square. And AD equals to 8. 8 square, AD square is 8 square, 8 square is 64. We open the brackets of this side of equation number 1 and we got that 12 minus R square equals to 12 square is 144 plus R square minus 24R equals to R square plus 64. We have R square on both sides of this equation, equation number 1. So R square will get cancelled And what is left from equation number 1, after we cancel the r square, what is left? Here in this side we left only with 144 minus 24r, and on the other side we left with 64. Here we added 60, we subtracted 64 from this equation number 1, and we got that 144 minus 64 is 80. So in conclusion we got that 80 minus 24r equals to 0. We added 24r to this equation number 1, and we got that 24r equals to 80. Here we divided this equation number 1 by 24, and we got that the radius of the semicircle equals to 80 over 24. Here we divided both the numerator and the denominator of this number by 8, and we got that 80 over 8 is 10, and 24 over 8 is 3. So in conclusion we got that the radius of the semicircle equals to 10 over 3 units, and the area of the semicircle is pi r square over 2. So pi r is 10 over 3, r square is 10 over 3 square. 10 over 3 square is 100 over 2, and 100 over 2 is 50. So in conclusion, we got that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So in the next step, I will present it to you how to find out the area of the semicircle according to a third method. Actually, I drew the mirror image of this figure, and then I combined this figure with its mirror image, and in this way we got a circle that is inscribed by a triangle. Okay, I will repeat again. I drew the mirror image of this figure, and I combined this figure with its mirror image, and in this way we got a circle that is inscribed by triangle ADC. And because of the fact that ABC is the mirror image of ABD, if AC is 13, then AD must be also equal to 13, and BC is 5, so DB must be also equal to 5. Therefore, DC equals to 5 plus 5, that is to say, DC, the base of the associated triangle ADC, is 10, and the height AB is 12 units. It is given as the question, and the area of triangle ADC is the base times the height over 2, that is the area of any triangle. The base of the associated triangle ADC is DC. The height is AB divided by 2. DC equals to 10 units. AB equals to 12 units. So in conclusion, the area of triangle ADC equals to 10 times 12 over 2. 10 times 12 is 120. 120 over 2 is 60. So we found out that the area of triangle ADC equals to 60 square units. Then we know that the radius of any circle that is inscribed by a triangle, like in this drawing, we have this circle that is inscribed by triangle ADC. The radius of this circle will be equal to the area of the triangle that blocks this circle. The triangle is triangle ADC, over the semi-perimeter of the triangle that blocks the circle, that is also the triangle ADC. We have already found out, so here we have the formula is R equals to the area of triangle ADC over the semi-perimeter of this triangle. Okay, so it is actually equal, I will repeat again, the radius of the circle that is described by a triangle is equal to the area of the triangle that blocks the circle, that is actually triangle ADC, over the semicircle of the triangle that blocks the circle of the semi-perimeter. And the semi-perimeter of any triangle is equals to the perimeter over 2. And the perimeter of triangle ADC equals to AD plus AC plus DC over 2. AD is 13, AC is 13, and DC is also 10. So 13 plus 13 is 26, 26 plus 10 is 36, and 36 over 2 is 18. So we found out that the semi-perimeter of triangle ADC is 18, and the area of triangle ADC is 60. So the radius of the circle that is inscribed by triangle ADC equals to 60 over 18. We divided both the numerator and the denominator of this number by 6, and we got that 60 over 6 is 10, and 18 over 6 is 3. So in conclusion, we got that the radius of the circle equals to 10 over 3 units, and it is actually also the radius of the semicircle, and the area of the semicircle is pi r square over 2. R is 10 over 3, and r square is 10 over 3 square. 10 over 3 square is 100 over 2, and 100 over 2 is 50. So the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. So we finished with the third method. Then I presented to you how to find out the area of the semicircle according to the fourth method. In the fourth method, we defined this angle, angle CAB is angle theta. We focused on triangle ABC. You can see that in triangle ABC, the big right triangle, sinus theta equals to CB over CA. I'll repeat again. In the right triangle, triangle ABC, sinus theta equals to CB over CA, but CB equals to 5 units. CA is the hypotenuse of triangle ABC that equals to 13 units. So in conclusion, according to equation number 1, sinus theta equals to 5 over 13. Then we focused on the green right triangle, triangle ADO. Here, sinus theta equals to DO over AO. Again, sinus theta equals to DO over AO. DO is R. AO is 12 minus R. So in conclusion, according to equation number 2, sinus theta equals to R over 12 minus R. And according to equation number 1, sinus theta equals to 5 over 13. We created equation number 3 that states that sinus theta according to equation number 1, that is 5 over 13, must be equal to sinus theta according to equation number 2, that is R over 12 minus R. So here we cross multiplied equation number 3, and we got that 5 times 12 minus R equals to 13R. We open the brackets on this side of equation number 3, and we got that 5 times 12 is 16, and 5 times minus R equals to minus 5R. We added 5R to this equation, equation number 3, and we got that 13R plus 5R is 18R. So in conclusion, we got that 18R equals to 60. We divided this equation, equation number 3 by 18, and we got that the radius of the semicircle equals to 16 over 18. The radius of the semicircle R equals to 60 over 18. We divided both the numerator and the denominator of this number by 6, and we got that 60 over 6 is 10, and 18 over 6 is 3. So we found out that the radius of the semicircle equals to 10 over 3 units. And the area of the semicircle equals to pi r square over 2. So pi r is 10 over 3, so r square is 10 over 3 square, divided by 2. 10 over 3 square is 100 over 2. And 100 over 2 is 50, so in conclusion, we found out that the area of the semicircle equals to either 50 pi over 9 square units, or in terms of numbers, it equals to 17.45 square units. Okay? Thank you very much.